All right, so in this video we're looking at 313 and 314. It's the Hindu inversion method and the modern method, which ultimately boil down to being the same thing. The Hindu inversion method is just an earlier iteration of that, where you just undo whatever the expression kind of requires you to undo. So when it says a number is doubled and then the result is squared, 2 is added to the result, and you have 38, what's the original number? It's just basically take that set of instructions and undo what's written there, and you'll get the value. So, basically the last thing that you did is something that you could consider being the first thing to undo. But really, as long as you carry out the reversion or the inversion of the set of instructions, then you're good. So the number is doubled, the result is squared, add 2, right? So do the opposite of that, subtract 2, take the square root, and then cut the value in half, right? So you can follow all that, but the modern method just kind of streamlines that into a set of processes where the process is, or the steps would be, identify your variable, which we typically call x, translate the given word problem into a mathematical equation, isolate x to solve the problem using the modern algebraic techniques, and then check your solution. All right. So in example 1, a number is doubled and the result is squared. All right. So before you even get into this, where it's the translating part, we can just say let x equal the number. All right. So I'll just, I'm basically doing what's there. I'm just going to kind of break it down a little further. All right. A number is double. So 2x would be the number doubled. Then the result is squared. So the result of doubling the number is squared. So 2x squared would be result is squared. Then 2 is added to the result, right? That new result. The result is squared is the result, which was the number doubled squared. So the new result is the number doubled and then squared. So I know it's a mouthful, but 2 is added to that, right, is equal to the result, or so 2 added to the result. And you get 38. So this result, 2x expression quantity squared plus 2 is 38. All right. And, it didn't say explicitly is 38. It said, and you have 38, but that would imply the same thing. And is tends to mean equal. So there you go. All right, so we're going to do the exact opposite of this. So whether you're using the inversion technique or just modern algebraic techniques, it's essentially the same thing. I'm going to subtract off the 2. All right, so I'd have 2x as a quantity squared is equal to 36. I want to get rid of that power of 2, so I would take the square root. All right, so the square root of anything to the second power would be just whatever the expression is that's being squared. All right, so essentially they cancel each other. There's no indication that we would be allowing for negative numbers here, but there's no indication that we're not. So we would make the assumption that when you take the square root of 36, that it could be a positive or a negative 6. The principal square root of 36 is just 6. But to allow for it to be any number, they didn't say only the set of whole numbers or positive integers or anything like that. It just said a number. So we have to allow for that it could be a negative also. And so I divide out the 2. and I would get x is equal to positive 6 divided by 2 is positive 3, negative 6 divided by 2 is negative 3, so plus or minus 3. And you can check by plugging it back into the original, air quotes on original equation. It's the one we came up with. So, most people who struggle with word problems, they struggle with that first step of getting an equation from the actual words. So assuming that our equation is correct, then you can pop this plus or minus 3 back into the original equation, simplify and verify. All right. So I'll just show you that very quickly off on the side here. So if I take that 2 and instead of an x, I would put in a 3. So 2 times 3 is 6. Squared is 36. I put a plus 3 for Lord only knows. That'd be a 2. 36 plus 2 would give you a 38. Or, and that's what we wanted, so we know we did that right. All right, so 2 times a negative 3 would be negative 6 squared, which is 36, plus 2 gives you 38. It checks out in both cases. Okay. Which means that both values, 3 and negative 3, contribute, or they end up being part of the solution, so they need to both be there. Right? So we can't just put the 3 instead of the negative 3. You don't get a choice. When we say it's 3, like plus or minus 3, that it's 3 or negative 3, it's not really a choice. These are two values that satisfy the equation. 3 would satisfy it, or negative 3 would satisfy it, but we have to present both as options. All right. 2 added to a number, the sum squared, and then doubled gives 50. What is the number? All right. So again, let x equal a number. Piece at a time. 2 added to a number. The sum squared. So take that result and squared it. And then doubled. So 2 times that result. Gives 50. All right. So 2 parentheses x plus 2 squared gives or is equal to 50. All right. So again, inversion technique or just ordinary algebra. What was the last thing we did? We doubled. So we divide. Instead of multiply by 2, we divide by 2. You can call it halving, like cutting in half. All right. So either way, amounts to the same thing. The sum squared, the inversion of squaring is square rooting. So x plus 2 is equal to plus, well, in this case we have to simplify. Oh, oof. No we don't. Because for some reason, I just didn't divide the 50 by 2. Look at me. That's 25. I was just getting ready to do a quick mini review on how to simplify radicals, but we'll get to that down the line. So plus or minus 5 square root of 25 is 5. All right. And then it was 2 added to a number, so let's subtract 2 from the number. So x would be equal to negative 2 plus or minus 5. We tend to put the plus or minus term off at the end. It's not a requirement, but it just kind of feels a little bit more compact, which is not a bad thing. But we're looking at negative 2 minus 5, or we use a little v symbol for or, negative 2 plus 5. So that would be negative 7 or 3. All right, either one of those would be a solution to the problem. And then we can do a little check here. So again, 2x plus 2 squared is equal to, well, it's going to be hopefully equal to 50. Now you can make a little note that this is a check. So 2 times negative 7 plus 2. And then we would have 2 times 3 plus 2. All right, negative 7 plus 2 is negative 5. Negative 5 squared is 25. Where's my... No, lost my undo there for a second. 2 times 25 gives a result of 50. And then 2 times 5 squared, again, 2 times 25, result also 50, which is what we wanted. So we're satisfied that our two solutions are correct. All right. And so that'll set you up for 313 and 314. Like I was saying before, the inversion method, the Hindu inversion method, and the modern method are essentially the same thing. What I did here is I applied either one of them depending on what you want to believe. All right, because by writing out all the things that were happening in generating the equation and then doing all those things in reverse, I'm either applying the Hindu inversion method, or I was just doing modern algebra. So if you want to believe that I applied the Hindu inversion method by listing this out and then going through and saying, and then I doubled, okay, that means I halved. And the sum squared, so square rooted. 2 added to a number, subtract 2 from the number. Ultimately, it boils down to the same thing, because like I said right in the beginning, the modernization is really just a streamlined, more symbolic version. I don't think I said symbolic, but more streamlined or efficient, or however you want to think of it, version of the Hindu inversion method, however you want to think of it, is they're equivalent, right? So that's a very long way of saying these, like whether you do it with the Hindu method of inversion or the modern method, you're really doing the same thing. So there's no need to do these problems each twice. You can just do them the way I showed you how to do it in the video the one time, and you've satisfied both requirements. All right, so again, that's 313 and 3.